Hello everybody, welcome to another agitated DWF video. This is the second part of an attempt to restore an Enertec Schlumberger 7151 multimeter. Part 1 video is linked down below in the description. As I have shown in the previous video, I have changed the LCD backlight LEDs. Now I've also added a new connector in the rear panel. I plan to use this connector for an external memory backup battery holder. As shown in part 1, the internal rechargeable battery leaked badly and damaged part of the PCB, so I've just soldered two wires that connect the backup line to the other connector. While working in this area, I've also noticed that the main switch was clearly reworked in the past and left with exposed connections, which is not a good thing. So I desoldered the wires again and added heat shrink insulators. Now it looks nicer and it's a bit more safe. For the external backup battery, I'll use a small holder for 3 AAA cells. And since I'm going to use normal non-rechargeable batteries, I've added a blocking diode on the positive wire and added proper insulating sleeve to avoid any contact with the negative wire. Even with the series diode, the voltage from the 3 alkaline cells is more than enough for a static RAM and clock backup. The battery holder will be attached to the side of the multimeter with a velcro strip. And it worked fine. The multimeter kept the internal clock running even when powered off. Also, I ordered a bag of new screws of the correct size for the case ones, because a couple of them were missing. As you have seen in the previous episode of this repair, some components were missing from the PCB when I got it. Most of the missing parts, circled in red in this schematic, belong to the AC analog front end, so initially I've just replaced them and the AC functions started to work again. However, when changing components on the analog front end, a new calibration is required to obtain again reasonably accurate readings. However, to calibrate a multimeter, we need a device that can supply accurate and stable voltages and currents, and that's something I don't have. Luckily, the calibration of this multimeter doesn't require exact voltage values, as long as they are stable and can be measured with another similar or better multimeter. In fact, I have an HP 3456A bench multimeter that I can use to compare the readings. Of course, even this instrument may be out of calibration, but at least it never required any work in the analog part, and most importantly, I cannot think about any alternative method with what I have at home. But there is another problem. To calibrate the higher voltage ranges, we need a source of high voltage going to about 700 volts, and that could be obtained with a power transformer, except the manual requires these AC voltages to have a 400 Hz frequency, so that rules out mains operated transformers. That would of course provide a 50 Hz AC voltage in this part of the world. However, a transformer like this still works even at 400 Hz, albeit with probably different voltage ratios. So all I need is a way to generate some low voltage 400 Hz AC signals. I have several instruments that can generate sinusoidal signals at audio frequencies. However, to drive a power transformer, I need to use an audio power amplifier. The one in this picture was made by my teenage self on a backlight PCB drawn with a paint pen and etched in a ferric chloride bath, and it still works fine. So let's try to drive a low voltage winding and measure the output of the 110 volts winding. It works. I'm increasing the output from the audio generator. Let's check across both 110 volts windings now. Yes, as expected, more or less twice the output. Let's check now a single tap of the 400 volts winding. And now let's check the full 800 volts winding. So the theory seems working so far. So by varying the output level from the function generator, I can obtain different output voltages at the frequency I want, up to 800 volts AC. Before starting the calibration attempt, I've also carefully cleaned the reworked areas of the analog PCB with isopropyl alcohol, since even a fingertip mark can spoil high impedance circuits if left in the wrong place. Then I've soon realized my plan wouldn't easily work. I've set the signal generator to 200 Hz now, and set the amplitude for about 20 volt on the HP multimeter. The 7151 is off by more than 200 mV. Now, if I switch to 400 Hz, the transformer ratio changes and now we get 25 volts with the same input amplitude. And anyway, the amplitude is never stable enough. To make a long story short, I've tried using different signal generators to try to have stable readings, but even with the HP339A, that should be the best audio generator I have at home, the readings didn't really got stable enough. Also, it was not a problem caused by the amplifier or the power transformer, since I've tried different combinations of them. As you can see in this picture, the AC voltage read directly from the signal generator is jumping a bit. This was an attempt to calibrate the 2 volts AC range anyway, but I decided that it would be pointless to calibrate the AC ranges with this kind of equipment. I've also checked the other functions against the HP multimeter. Here you see some precision resistors measured with the same set of clips. The values are not too different between the two instruments. Now let's try with a DC power supply output. And let's enable the full 6 digits on the HP anyway. Also in this range, the two instruments seems agreeing quite well. But this power supply output is never too stable. So let's try with a battery. Now they seem to disagree a bit more. Anyway, that's all for today. I hope this was interesting and that you learned something. If you have any question, please use the comment section below. Have a nice time and thank you for watching.